Welcome to the Deep Dive. Today we're plunging headfirst into a, well, really fascinating space where creativity meets strategy. It's that intersection of game development and digital marketing. Have you ever found yourself wondering, not just how to build a really fun, engaging game, but also, and this is crucial, how you actually get that game into the hands and onto the screens of millions of players all around the world? We're focusing today on an incredibly accessible tool, but one that's surprisingly powerful. Construct 3.
That's absolutely right, yeah. Our mission for this deep dive basically is to give you a really comprehensive primer on using Construct 3, specifically for creating a very popular type of game, a 2D block-based physics, stacking, and balancing hyper-casual puzzle. You see those everywhere. But we're not stopping there. We'll also navigate the, frankly, critical world of playable ads. We're going to dissect precisely how to craft them so they are not just incredibly engaging, but also fully compliant. With all the strict requirements from the big ad networks like Unity, Facebook, and Google.
Right, and we've meticulously pulled together insights for this. We've looked at the official Construct 3 documentation, gleaned practical wisdom from expert developer forums, and drawn authoritative guidance from industry leaders, people like the Interactive Advertising Bureau, Activision Blizzard Media. Our goal is pretty clear. We want to arm you with the nuanced knowledge you need for game development in Construct 3, and also help you master that strategic art of successful ad creation. So prepare for some genuinely surprising facts at that, and definitely more than a few aha moments along the way. So let's kick things off with the absolute fundamentals then. What exactly is Construct 3, and why is this particular game engine, generating so much buzz right now?
Okay, so Construct 3, at its heart, it's a powerful engine. It's performant, incredibly capable for game development, and the really unique thing, it operates right in your browser. Think of it like a professional studio, but it lives entirely online. Its core strength, and honestly, its biggest differentiator is its visual scripting system. Some call it block-style scripting. And this visual approach, well, it really democratizes game development. It makes it incredibly accessible for like a whole spectrum of creators.
Okay, so accessible whether you're, say, a seasoned decoder or someone who just has great ideas, but maybe no programming background.
Exactly, yeah. Whether you prefer traditional coding or you've never written a line of code before. And it's built entirely on HTML5 Hypertext Markup Language version 5. That's super significant because it means any game you create with Construct 3, well, it runs smoothly, universally, across pretty much all modern platforms and devices, desktops, mobile phones, you name it. And crucially, without relying on old plugins like Flash.
Right, Flash, remember that. So that broad reach is a massive advantage then.
Huge advantage, yeah.
So if I'm understanding this right, it's really about taking game creation out of those highly specialized programming environments and putting it into the hands of a much wider audience, letting more people bring their innovative game ideas to life.
Precisely. It levels the playing field, absolutely.
And the fact you can develop in your browser, that's genuinely a game changer. Removes that whole barrier of complex setup and configuration.
It really is. Now, while it is incredibly user-friendly, very accessible, it's vital to understand where Construct 3 truly excels. And also, where it might have certain limitations. For smaller, more focused games, especially 2D games, it allows for exceptionally rapid prototyping. You can get something up and running fast. And let's be clear, it's not just for hobby projects. We've seen major commercial successes built entirely with Construct 3.
Oh, really? Like what?
A prime example is Moonstone Island. It's a game with a surprisingly large scale. People often compare it to Stardew Valley, and that was all Construct 3. So that demonstrates its viability for serious commercial-grade projects. It proves it's not just a beginner's tool.
Okay, Moonstone Island, yeah, I've heard of that. But that raises a really interesting point. What about those truly massive games? Hyper-complex ones with incredibly intricate systems, sprawling worlds. Is there a point where that visual scripting just hits a wall, where you have to bring in traditional code?
That's an excellent question, and it gets to the nuances of any game engine, really. Look, you can certainly get pretty far, and I mean remarkably far, with Construct 3's block-based visual code. But yes, some highly complex, deeply architectural systems, they could become cumbersome. Challenging to manage only with visual blocks. Imagine like building a whole operating system with Lego. Possible, maybe. Efficient, probably not. Now, Construct 3 does support JavaScript. That's its saving grace here.
Okay, so you can extend it?
Exactly. You can significantly extend functionality by integrating JavaScript, especially for custom behaviors, complex algorithms, maybe connecting to external code libraries. That's how many advanced users really push its boundaries. However, and this is important to clarify, it's not a complete plain JavaScript engine. Not like if you were developing directly with something like Phaser or Pixie.js.
You can just rewrite the whole engine or something.
No, exactly. You can't just write a whole game from scratch purely in JavaScript within Construct or fundamentally alter its core mechanics. It has limitations in creating entirely new engine-level behaviors or implementing those really abstract architectural patterns you see in engines like Unity or Unreal. Its foundational strength, its sweet spot remains firmly rooted in its 2D event-driven nature, though to its credit, it does offer some pretty compelling 2.5D features for visual depth. So yeah, while it offers a path for more traditional coding, it's more about extending its existing framework, not building a totally new one inside it.
Gotcha. So given that nuance, if someone is starting a serious project in Construct 3, what fundamental practices, what core disciplines should they really focus on right from the start to avoid that, that dreaded mess of sprites and stuff that just derails everything later?
Right. What's fascinating here, and I really can't stress this enough, is just how utterly crucial the early adoption of certain core features and discipline practices can be. Seriously, doing this right can save you days, maybe even weeks of just needless work and painful refactoring down the line. Trust me.
Okay, I'm listening. What are the essentials?
First and foremost, you absolutely must prioritize learning and consistently using features like families, containers, functions, global layers, arrays, dictionaries, and timelines right from the outset. Don't think of them as optional extras. They are foundational for making your project maintainable and scalable. Families, in particular, are vital. My strongest advice, and you hear this from countless experienced devs, is create them immediately. Like when you add your very first enemy, your first character type, any object you might reuse, create a family for it then and there. Apply behaviors, instance variables, apply them to the family, not the individual objects.
So group them logically from the start.
Exactly, because trying to upgrade a whole scattered bunch of individual objects into a nice, neat family later on, oh man, it's genuinely difficult. It's boring. It's a soul-crushing task. It is so much easier to just do it right from the beginning.
That makes total sense. It's like architectural planning for your code, basically. Establish that clean, modular structure early.
Absolutely. Think of it exactly like that. Good architecture. Beyond just adopting those features, the core principles of code organization and readability are just non-negotiable. It sounds basic, I know, but consistently name your objects properly, give them meaningful names, and organize them into logical folders within your project. It seems small, but months later when you're hunting for one specific sprite, you'll thank yourself.
Future. You will definitely appreciate it. And cultivate the habit of commenting your code clearly. Don't just say what a line does, explain why it's there. What's its purpose? What assumptions does it make? You're writing for your future self, or maybe collaborators. And critically, please avoid using hard-coded values and magic numbers.
Magic numbers, what are those exactly? They're just arbitrary numbers embedded directly in your code with zero explanation. Like player speed, y5. What does 5 mean? If you need to change that speed later or use it elsewhere, it's a nightmare to find and update consistently. Instead, use named global variables or instance variables, like player-based speed equals 5. Now it's self-documenting, easy to find, easy to tweak, everywhere at once. Makes your code much easier to understand and modify.
Right, that makes perfect sense for keeping the actual code, the events, clean. But what about managing dynamic data within the game? Things like player inventory, high scores, maybe complex puzzle states. Are there specific tools in Construct 3 best for handling those kinds of structured data sets?
Yes, absolutely. For effective data management, especially when you need to save game progress or store complex info, arrays and dictionaries are your best friends. Let's break those down. An array is essentially an ordered list. Think of it like a spreadsheet row or maybe a grid. Each cell holds a value, a number or text. Arrays in Construct 3 are really versatile. They can have 1, 2, or even 3 dimensions. Think width, height, depth. The position of a cell is its index, and it always starts counting from 0, not 1, remember that. This makes arrays invaluable for storing large, structured data sets, like a tiled game map, or a list of items in a player's backpack, or even the step-by-step setups for a series of puzzles.
So a 3D array could hold a whole level layout.
Exactly. Block types, positions, properties. You could store an entire level's layout in a 3D array. Makes dynamic level generation or editing way easier. The aha moment here is realizing how a 3D array can take really complex data relationships and just abstract them away into a surprisingly manageable structure, like for a dynamically generated puzzle board.
Okay, that's arrays. What about dictionaries? How are they different?
Dictionaries offer a different kind of power. They're incredibly helpful for saving and retrieving lots of variable data all at once. But instead of using a numerical index like an array, you use unique strings text labels as keys to look up specific values. So instead of remembering player data might be health, you just use a descriptive key like player data health or player data current level.
Much more readable.
Way more readable, super convenient, makes your data management much cleaner, especially for saving diverse player stats or game configurations. Now, some developers occasionally note that only using strings for keys can be a minor limitation in really specific high-performance scenarios where maybe numerical lookups are technically faster. But honestly, for most game data management, dictionaries are fantastic. And the really great news, both arrays and dictionaries can be effortlessly saved to and loaded from JSON strings.
JSON JavaScript object notation.
That's the one. Using Construct 3's built-in local storage plugin. This capability is absolutely vital for saving game progress. It lets players pick up right where they left off, even if they close the browser or app. It's a backbone of any decent save system.
Okay, that's crucial. And finally, a piece of advice that seems almost too obvious, but, well, it's so often neglected, usually with devastating consequences.
Yeah.
Backups.
Oh, boy. You're hitting on maybe the single most critical piece of advice for any developer using any tool. A robust backup strategy isn't just non-negotiable, it is the bedrock of your sanity. You must back up your projects, at least once a day. Ideally, more frequently if you're making rapid changes. Hardware fails, software crashes, accidents happen, we've all been there.
We have, painfully.
Painfully, yes. Now, Construct 3's Cloud Save feature, it's excellent. Genuinely great for offsite protection. Your work's safe even if your computer explodes, but you absolutely must maintain secondary local backups too. Think of it as an extra layer of defense. What if you lose access to your account? What if the cloud service has an outage?
Right, belt and suspenders.
Exactly. Construct 3 even helps here. It can automatically make periodic backups to a local folder. But to make this truly robust, you should ideally set up that local folder to sync automatically with a cloud service like Dropbox or Google Drive, OneDrive, whatever you use. That gives you true offsite protection and version history. The golden rule here, and I've seen countless developers learn this the hard, painful way. Do not wait until you've lost work to start backing up. People lose work constantly due to bad backup habits. Don't be one of them. Be proactive. It saves so much future pain.
Sound advice. Okay, so we've covered those foundational development practices. Now let's talk about bringing game objects to life. How does Construct 3's built-in physics behavior let you manipulate objects and create that realistic movement, which is, so crucial for a stacking game like we're discussing?
Right. The core fun, and honestly the challenge too, of Construct 3's physics behavior comes from applying various physical concepts. These let you create incredibly dynamic interactive environments.
Like what concepts?
Well, first, you have forces. Imagine these as continuous influences. They consistently push or pull an object, causing it to change speed or direction over time. Think of gravity constantly pulling things down, or maybe a persistent gust of wind pushing things sideways. In Construct, you apply a force over time to accelerate an object. You can specify its strength, its direction along X and Y axes, or even apply it towards a specific angle or a point on the object. Great for environmental effects, propulsion, that kind of thing.
Okay, continuous forces.
What else? Then you have impulses. Now, unlike forces, impulses are one-off hits, like a sudden, instantaneous burst of energy, a quick push, a sharp impact. Impulses are best used in triggered events. For instance, when one object collides with another. Or maybe when the player taps to drop a block in your stacking game, that initial push downwards, that's an impulse. And just like forces, you can specify X and Y components, apply it at an angle, or direct it towards a particular point.
Got it. Forces are continuous, impulses are sudden hits. What about rotation? Blocks need to tumble.
Exactly. That's where torque comes in. This is a rotational force, different from linear forces. It affects an object's angular velocity, basically, how many degrees per second it rotates. A positive torque value usually means clockwise rotation, negative means anti-clockwise. Torque is absolutely crucial for making blocks tumble, spin, rotate realistically when they fall, get hit, or land awkwardly in your puzzle.
Okay, forces, impulses, torque. Anything else in the physics toolbox?
Yes, joints. These are really powerful tools. They let you connect two or more physics objects together in fun, complex ways, creating interactions beyond simple collisions. For example, the revolute joint. It acts just like a hinge, pins one object to another, but lets them rotate freely around that point. Think swinging doors, rotating arms on a machine, levers. Then there's the distance joint. This makes two objects behave like they're connected by a rigid, invisible pole. They always maintain a constant distance. What's really cool with distance joints is you can add a damping ratio and spring frequency.
So make it springy.
Exactly. Makes the connection behave much more like a spring. Allows for realistic oscillations, a more dynamic, bouncy feel, as objects react to movement or impact. Really useful for certain mechanics.
It sounds like you have incredible precision over where and how these effects are applied. Can you actually apply, say, a force or an impulse from a specific point on an object, not just its center?
Yes, absolutely. And this is a game changer for getting nuanced realism. For forces and impulses, you can specify an image point on the object. That's any designated point you set up. You're not just stuck with its default origin or center. This allows for incredibly precise, realistic interactions. For example, if you apply a force or impulse from the edge of an object, it's far more likely to rotate it, makes it tumble and spin. Apply that same force from the middle, it tends to make it move more linearly, almost floaty, or maybe orbiting if there's a pivot involved.
Okay, that makes sense. Hit it on the edge, it spins. Hit it in the middle, it moves straight.
Pretty much. And here's a crucial point. Ties right back to real-world physics. Remember Newton's second law, F. Force equals mass times acceleration. What this means in practice. A given force or impulse will have a much, much greater effect on a light object than a heavy one. So you'll constantly need to adjust the values for your forces, impulses, torque, based on the mass you assign to your objects. Getting that realistic, satisfying behavior is all about balancing those values.
So it's an art as much as a science.
It really is. Sometimes, for a heavier block to feel right in a stacking game, you might deliberately give it slightly less mass than its visual weight suggests, just to allow for a more satisfying tumble or maybe prevent the whole stack from instantly collapsing. It's a common trick, balancing that realism with enjoyable playability.
Interesting. Speaking of taking things to the next level, what about venturing into 3D? I heard whispers of a new plugin shaking things up for 3D physics in Construct 3.
Oh, this is incredibly exciting. Yeah, a significant leap forward. There's an innovative new plugin currently in development. It's called Malai Games' Canon 3D Physics plugin. It's built on Canon.js, which is a lightweight 3D physics engine written purely in JavaScript. Now, it's currently in what they call a bare bones implementation. It's free right now, but the developer has clear plans for it to become a paid plugin as more features get added.
So they're serious about developing it further.
Exactly. It signals a real commitment to its future within the Construct 3 ecosystem. And it represents a huge step for true 3D physics capabilities in Construct. Opens up entirely new genres, new mechanics.
Fantastic news for anyone wanting to push those boundaries. So in its current bare-bones state, what can this plugin actually do right now, and what advancements can developers look forward to?
Okay, currently it primarily works with Construct 3's native 3D shapes. Things like boxes, wedges. It doesn't yet support full, complex 3D models imported from external software like Blender, but that's definitely planned for future updates. A current limitation, which users of Construct's native 3D shapes know, is that objects can only rotate along the z-axis vertically. But the developer has explicitly stated in their roadmap they plan to enable rotation in all three axes, X, Y, and Z. That would be transformative for dynamic, realistic 3D interactions.
Total game changer for 3D in Construct.
Absolutely. They also plan to add more basic shapes like cylinders to expand its versatility. Beyond shapes, the plugin already supports applying impulses directly to an object center, so you can give them sudden pushes, just like our 2D impulses. You can also easily set objects as immovable. Perfect for creating static things like ground planes, solid walls, things physics objects should react against but not move. Naturally, you can control global gravity settings, and it can perform 3D raycasts.
Raycasts.
Well,
For hit detection.
Exactly. Crucial for precise hit detection, line of sight checks, things like that in a 3D space.
I remember seeing a demo you mentioned with a car hitting cones. Sounded really compelling, highlighting how objects would naturally react.
Yeah, that demo perfectly illustrates the core advantage. In the past, getting truly realistic collisions, especially with multiple objects, you often had to manually tween things or use complex pre-scripted animations to fake the collision, which could be incredibly cumbersome, resource-intensive, and often just felt less convincing for complex scenarios. But by applying actual physics with this plugin, objects react a little bit more naturally. They bump, they tumble, they settle exactly as you'd expect in the real world, without you needing to meticulously animate every single interaction.
Less faking it, more emergent behavior.
Precisely. Emergent gameplay. And from a performance standpoint, That demo with, what was it, 230 physics-enabled cones. The CPU usage stayed remarkably reasonable, around 35%, which shows significant promise for scaling up physics interactions in more complex games without grinding everything to a halt. This tech genuinely opens up a whole new realm of possibilities. Realistic projectiles, destructible environments, intricate catapults where the physics engine itself dictates the outcome, not just pre-scripted animations.
Very cool. Okay, so bringing all this physics knowledge together, what does it actually mean for building our target game? Let's zoom right in now on designing that 2D block-based physics stacking and balancing hyper-casual puzzle game using Construct 3.
Okay, let's start by firmly defining hyper-casual in this context, because that term really dictates so many design decisions. These games are meticulously designed to be easy to play, extremely accessible. Often they need zero tutorial, no lengthy instructions. They're typically playable even whilst multitasking, quick bursts during a commute, waiting in line. And their target audience, they might not even identify as gamers in the traditional sense.
Right, games for everyone, basically.
Pretty much. And Construct 3 and HTML5, they're fantastic fits for this genre. Why? Low development budget needs, rapid prototyping, and that massive reach across all sorts of devices. Perfect combo. Now, for any puzzle game, the emphasis is fundamentally on puzzle solving. That could be logic, patterns, or in our specific case, the often unpredictable fun of physics.
So how do you apply that to stacking blocks?
Okay, core mechanics. The puzzle has to revolve around a single, central, compelling mechanic for stacking and balancing. That's the realistic interaction of blocks under forces. You'd be heavily using Construct 3's physics behavior, applying continuous forces like gravity, one-off impulses from player taps or drops, maybe even joints to create dynamic, unpredictable interactions as blocks land and react to each other. The core loop is just super simple. Place a block, see if it balances, repeat. That's it.
But how do you keep it engaging? How do you balance challenge without frustrating players? Especially that hyper-casual audience who might just bail if it gets too hard too fast.
That is the critical balancing act. It brings us to difficulty and progression. You need to meticulously design that difficulty curve, make puzzles just challenging enough to avoid boredom, but never so tough that players get frustrated and quit. For hyper-casual, this almost always means a very linear progression. Puzzles get incrementally harder. Gradually introduce new block shapes, maybe different materials like slippery ice blocks versus sticky ones, or environmental challenges like moving platforms, maybe wind. And immediate, clear player feedback is absolutely crucial. Visuals, sounds.
Like a satisfying thump.
Exactly, a satisfying thunk when a block lands perfectly, or maybe a dramatic wobble sound just before it topples. That provides instant gratification or immediate warning, communicates success or failure without needing any text.
Interesting, too. You mentioned this blend of analog versus digital mechanics. Can you expand on that?
Yeah, it's a fascinating aspect of these games. While the act of placing a block might be digital, you tap a button, it drops from a set height, or you drag it, the physical outcome, whether it balances or falls. That introduces this wonderfully analog element. Slight variations in placement, the exact angle it falls, the weight distribution of the whole stack. These have free form, often unpredictable consequences. It's just like a real game of Jenga, right? Small nudges can lead to dramatic collapses. That analog unpredictability is key to replayability, keeps it feeling fresh.
And you stressed prototyping earlier. How important is that here?
Crucially important. You must relentlessly prioritize prototyping. Use placeholder graphics, the absolute simplest code you can. Just test and refine those core physics mechanics early and often. Get feedback from actual players, even with rough prototypes. This iterative process is essential to find that perfect balance of challenge and fun. Make sure the core game is genuinely enjoyable before you invest heavily in polish, in art assets. Don't fall in love with your first idea. Iterate until it feels right.
So nail the core gameplay loop first, then make it pretty. But once you have that fun core, how do you keep players coming back?
Yeah.
Especially in hyper-casual, where sessions can be so short.
Right. For sustained engagement and flow, you can implement simple, intrinsic rewards, things that make players feel progress. Maybe unlocking new block skins, different visual effects for successful stacks, or just a clear progression screen showing their mastery over previous levels. And remember, in hyper-casual, explicit, text-heavy tutorials, they often get skipped. Players are impatient, so the interactivity, the core gameplay, it has to be immediately apparent. Players should figure out how to play just by touching the screen for a few seconds. Intuitive design is key. And here's a subtle but important point for progression design. It's generally better to design puzzles that cannot be skipped.
Even with in-app purchases.
Yeah, even with IAPs. While letting players bypass challenges might seem like it reduces frustration in the short term, it can actually hinder learning. It can lead to much greater frustration down the line when they hit harder levels they haven't been properly prepared for by mastering the earlier ones. It's about building those foundational skills level by level. Don't let them skip the learning process.
Okay, that makes a lot of sense. So we've explored building a great game idea in Construct 3, the next massive challenge, getting people to actually discover it, play it. That's where playable ads really come into their own. So what makes them such a powerful, almost transformative force in mobile marketing today?
Playable ads are, and I don't think this is an exaggeration, a truly transformative ad format. They fundamentally change the user acquisition game. Instead of just passively watching a video or glancing at a static image, users get to actively experience a mini version of your mobile game, right there, inside the ad unit itself. This try before you buy approach. It's incredibly effective. It builds immense trust, genuine curiosity. It transforms that typical passive ad encounter into an active, engaging, highly memorable experience, drives significantly higher engagement, and crucially, much better recall for your game.
It's like offering a free sample at the grocery store, isn't it? Before you commit to buying the whole thing.
Exactly. It's the perfect analogy. A delicious free sample.
So it's really about attracting quality players, not just quantity, ensuring you get people who are genuinely interested and likely to stick around.
Precisely. Playable ads act as this powerful filter. They effectively sift out low-intent users, people who might click a generic ad but have zero real interest in your specific game. This ensures you're acquiring higher quality installs. Players who genuinely understand and hopefully like your core mechanics right from the start. These users are far more likely to convert into long-term engaged players and, importantly for the business side, become paying customers. The ROI stats here are just incredibly compelling. Playables achieve 3 to 7 times higher conversion rates compared to standard video ads.
3 to 7 times.
Oh.
Wow.
Yeah. They boast an impressive average install rate of 5.8%. Compare that to the typical 1.2% for standard display ads. It's a huge difference. What's more, you see a significant 40% higher day 7 user retention for players you acquire through Playables. They stick around longer. And maybe most impressively for marketers, they can result in a 33% lower cost per install, or CPI. So they're more effective and more efficient. Huge win on all fronts. Now, what's truly fascinating here is just how precise, how meticulous the design of a playable ad needs to be. You have such an incredibly short window of opportunity to capture attention and get someone to act.
It's seconds.
Literally seconds. First, you absolutely must create a strong hook. You're maybe 3 to 5 seconds tops to grab attention. Your ad needs to start with an immediate challenge or an enticing offer or just striking visuals that instantly make your ad pop out from all the noise online. Those first moments are absolutely make or break. If you don't hook them instantly, they just scroll past, gone. Think about making the first interaction a mini game itself, or presenting a clear problem the user needs to solve right away.
Okay, hook 'em fast. What's next?
Second, keep it brutally simple and intuitive. Users must grasp the core mechanics instantly. There is zero time for complicated tutorials. Use short, clear instructions. Ideally, pair them with bold, animated visual cues. An eye-tracking study actually showed players engage 1.4 times longer with instructions that effectively combine text and imagery. Even better, consider a very brief dynamic instruction screen after the initial launch. Use animated icons, not just static text. That can capture attention for about 4 extra seconds, helping ensure those vital initial instructions are understood before the main gameplay starts. Show, don't just tell.
So, for Playables, it's demonstrate the core appeal quickly, clearly, almost entirely through visuals and interaction. Less text, more action.
Precisely. You need to highlight your core features with extreme efficiency. Showcase what makes your game unique. Its central loop, an exciting level, a special ability. But always remember, keep it lean, keep it web-friendly. This is a free sample, not the whole meal. Don't try to cram every single game feature into the ad. That's a common mistake. You also must show interactivity with crystal clear visual cues. Make it immediately, undeniably obvious that this thing is interactive, not just a static image or a passive video. Use those recognizable signals. Animated hands guiding a tap, pulsing buttons inviting interaction, prominent tap-to-play prompts. Right from the very beginning. Any static image at the start is just a lost opportunity. It won't grab attention in that fleeting moment.
Makes sense. Get them tapping right away.
Exactly. Fifth, and this is totally non-negotiable, optimize for mobile. The vast majority of these ads are seen on smartphones. Millions of different screen sizes, resolutions, network conditions. You have to design your ads specifically for mobile screens, intuitive touch controls, and critically, extremely fast load times. Ensure smooth performance across various devices, various network speeds, prevent frustrating lags, stuttering crashes. A slow-loading ad is a failed ad, period.
And finally, the call to action.
Yes, use strategic calls to action, CTAs. A clear, compelling, well-timed CTA is essential. It guides users forward after they've had that interactive taste. Place it strategically, usually after the main interactive part once you've hopefully captured their engagement and curiosity. Make CTAs prominent, easy to tap. Offer a clear value proposition. Be direct. Play the game now, or download to unlock more levels, something like that. Avoid vague stuff like tap to learn more. Be specific about the benefit.
What about when to show the CTA? Is there an ideal time?
Good question. While some general advice might say 10-30 seconds, more nuanced, data-driven approaches often work better. You might consider a teaser CTA around 15-20 seconds in. Catches those early, high-intent users. The main CTA is often best placed around 30-45 seconds. That's frequently when peak user engagement happens in the ad. And then maybe a final CTA on an end card, perhaps with some urgency messaging for those who complete the whole experience. But the ultimate key here, rigorous A/B testing. You have to test to find out what specific timing sequence works best for your ad, your game. It can definitely vary.
That's a really comprehensive breakdown of effective design principles. But how do we make absolutely sure these ads not only look great, but also load lightning fast and run smoothly on every phone, especially when they need to be so incredibly lightweight for the ad network?
All right. Performance optimization isn't just a nice to have. It's absolutely paramount. You have to avoid user frustration and maximize engagement. Users simply will not wait for a slow ad, nor will they tolerate a laggy one.
So where do you start with optimization?
Asset compression, first line of defense, and it's vital. You need to be aggressive here. Compress all your image assets. Use tools like TinyPNG, ImageOptim. They significantly cut file size without much noticeable quality loss. Similarly, minimize and uglify your JavaScript and CSS files. Tools like Cursor or Uglify.js do this, the overall goal. Keep the total uncompressed file size under 2 MB for strict platforms like Facebook, and typically under 5 MB for other major platforms. For those high-density Retina displays, use higher quality images only for logos, critical UI elements, things that really need to pop, not for large background images or less critical stuff which can eat up memory. And if you include any short video clips, make sure those files don't exceed 50 MB. Every single byte counts. Ad networks want these loading instantly, even on slow connections. Prevent users bouncing before they even see it.
Okay, compress everything. What else?
Consider lazy loading. This technique significantly improves initial load times, reduces immediate memory use. Instead of loading everything at once when the ad starts, you load only the absolute essentials needed for the very first interactive moments. The rest of the ad's content, maybe later levels, extra characters, fancy visuals, gets progressively loaded during gameplay or as the user interacts. Prevents that long, frustrating initial wait. Keeps them engaged from second one.
Smart. Load only what's needed right now.
Exactly. Then there's canvas optimization. For truly smooth animations, always use request animation frame for your game loop, not less efficient things like set interval. Request animation frame syncs your animations with the browser's refresh rate, leads to a much more fluid experience. You also need to minimize unnecessary canvas redraws and actively batch rendering tasks. Group drawing operations together, update the screen less frequently but more efficiently, drastically improves performance, frame rates, makes it feel really fluid and responsive.
And memory. Is that a big concern?
Oh, absolutely. Memory management. Often overlooked but vital for preventing crashes and slowdowns, especially on lower-end devices. You need to actively clear unused objects and textures from memory once they're no longer needed. Prevents memory leaks, stops the ad getting bloated and slow over time. Also, pay close attention to managing your sprite sheet sizes efficiently. Ensure your images fit into power of 2 dimensions, like 256 by 256 pixels or 522 by 512, not odd sizes like 258 by 258. Non-power of 2 dimensions can force the engine to allocate larger, less efficient texture spaces. Consumes more memory than necessary. It's a subtle but important optimization.
It's incredibly detailed advice for optimization. But this raises an important question. How do you actually know if all these clever design choices, all this optimization work is truly paying off in the real world? It's not enough to just launch it and hope, right?
You are absolutely right. Hope is definitely not a marketing strategy. That's precisely where advanced A/B testing methodologies become completely indispensable. It's the cornerstone of continuous optimization. You simply cannot guess what works best. You have to measure it rigorously.
So what kinds of things should you be A/B testing?
All sorts of things. You need to systematically test various variables to fine-tune your ads for maximum impact. Experiment with different tutorial lengths. Make a 15-second version, a 30-second, maybe even 45 seconds. See which performs best. Test different CRA button placements, different designs, different wording. Test how the game's difficulty progresses within the ad itself. You can test different reward mechanisms shown in the ad, or even completely different visual themes, different art styles. See what resonates most with your target audience. The possibilities for iterative refinement are huge.
Okay, so you test lots of variables. How do you structure that testing?
Good question. For your testing framework, always start by developing a clear, measurable hypothesis. Something like, a shorter tutorial in the ad will lead to a higher completion rate and a better install-to-impression ratio. Make it specific. Then, divide your audience into at least 2 groups, make sure they have similar characteristics, run both ad variants simultaneously, and then track key metrics with unwavering discipline. Metrics like the install-to-impression ratio, ITI, how many impressions turn into installs, cost per install, CPI, the average time to first click within the ad completion rate, and ultimately, return on ad spend, ROAS. Once a clear winner emerges based on that hard data, you can confidently scale that winning variant to a broader audience. You know it's data-backed.
And this isn't just a one-time thing.
Definitely not. It's an iterative process. You need to keep repeating the A/B testing cycle, use the insights and data from each test to form new hypotheses, and just keep refining. Meta's internal data, for example, shows that campaigns consistently following this test-error-learn-scale model, they benefit from a demonstrable 16% lower cost per action and a 29% higher conversion rate. Compelling proof that continuous, data-driven refinement really pays off in this super competitive mobile ad space.
But it's not all smooth sailing, presumably. What are the challenges?
No, it's definitely not without challenges. You often face higher production costs for playable ads compared to just static images or simple videos. And they demand a blend of specialized skills, game design, coding, marketing mechanics. Not everyone has that combo in-house. There's also the constant risk of user frustration, maybe from confusing instructions, slow loading times, or maybe the most damaging, a mismatch between what the ad promises and what the actual gameplay delivers. That's a huge complaint you see on forums like Reddit all the time. Bait and switch. And finally, ad fatigue is very real. Users get tired of seeing the same ad over and over. This demands regular creative updates, maybe personalization, to keep your ads fresh, engaging, and effective over the long haul. It's a dynamic field, requires constant innovation, constant adaptation.
That's a critical point about keeping things fresh.
Okay.
But once your playable ad is polished, optimized, tested, and ready to fly, it needs to play nicely with all the different ad networks out there. What are the universal rules, the general requirements that HTML5 playable ads need to stick to, regardless of where they're being served?
Right, the baseline rules. Generally speaking, HTML5 playables are typically delivered to networks as compressed ZIP files. That contains all your assets, your code, or sometimes as a single inline HTML file where everything's self-contained. A key technical requirement across the board. They must be responsive, meaning they need to seamlessly support both portrait and landscape orientations, adapt to how the user's holding their phone, a really important user experience, and compliance point. Audio is almost universally muted by default when the ad first plays, gives the user control, prevents a jarring blast of sound.
Makes sense. Any industry standards they need to follow.
Yes. Strict adherence to the Interactive Advertising Bureau, IAB, creative guidelines is absolutely crucial. These guidelines cover things like providing the player a clear, prominent option to exit the ad experience, usually within the first 30 seconds. They emphasize prioritizing the overall user experience through various UX safeguards, and focusing on tracking genuine engagement, not just raw impressions. Many platforms also explicitly require compliance with MRAID 2.0 standards. That's Mobile Rich Media Ad Interface definitions. It's a common API ensuring rich media ads can interact consistently with mobile apps. The IAB Tech Lab Creative Standards MyMe Types framework also helps ensure your creative assets render consistently across diverse systems, avoiding unexpected visual glitches. Follow the standards.
Okay, IAB and MRAID. Got it. Now let's really drill down into the specifics.
Yeah.
What are the unique nuances, the hard requirements for the big players, the ones developers target most often? Google Ads, Facebook, Unity Ads.
Right. Each major network definitely has its own specific, sometimes quite finicky guidelines you absolutely must comply with, or your ad just won't run.
Let's start with Google Ads.
Okay, Google Ads. Playables are typically submitted as an HTML5 package bundled into a ZIP file. The maximum uncompressed size they allow is 5 millibit. They fully support both portrait and landscape. Audio muted by default, as usual. It is absolutely mandatory to use exit.api.exit for all your call to action interactions. Google provides this specific JavaScript function to manage the ad lifecycle correctly within their system. You have to use it. Google also offers a dedicated playable ad testing tool, invaluable resource. Use it to validate your ad's compliance before you submit. Now, historically, Construct 3 exports sometimes faced issues with Google Ads. They didn't always play well with external.json files, and Google used to have a stricter 1 MB limit for standard HTML5 exports, making compression even more critical. Furthermore, Google Ads often requires advertisers to meet certain criteria like having spent over $1,000, having an account at least 90 days old just to be eligible to run HTML5 ads. It's not always available for brand new advertisers. All this just underscores why rigorous testing with Google's own tools is non-negotiable. What works perfectly fine elsewhere might just fail completely on Google Ads.
Okay, noted. What about Facebook? What are their quirks?
Facebook, they have their own distinct set of rules. Their playables require a responsive HTML or HTML format. The core playable code must be in JavaScript. The file size limit is quite strict, maximum of 2 millibit. Emphasizes extreme optimization. Get those assets tiny. Crucially, Facebook ads must avoid any HTTP requests and external redirects. Everything needs to be entirely self-contained in the ad package. Construct 3 exports previously ran into issues with something called blob.url. Facebook's system would mistakenly flag these as external requests, leading to false blacklisting. Nightmare. Now, Facebook is gradually moving towards accepting .zip formats, which might resolve this eventually. But for maximum efficiency and compliance right now, it's essential to inline your playable source file and use base64 data where possible. Keep it all self-contained.
Right, keep it all inside the package for Facebook. And Unity ads, they're big in the gaming space.
Unity ads. Yes, they're specifically optimized for game-like experiences. They heavily leverage WebGL, that's the JavaScript API, for rendering 2D and 3D graphics in browsers. They typically require a single HTML file, usually named index.html, with a maximum file size of 5 millibit. Like many others, ads must comply with MRAID 2.0 guidelines, and Unity places a strong emphasis on responsive touch interaction. They often feature a 30-second trial period within the ad. Lets users really engage before prompting for a download.
Okay, so Google, Facebook, Unity, any other notable platforms developers should maybe keep an eye on if they're looking to cast a wider net.
Yeah, absolutely. It's a diverse landscape. Briefly, some other key players include ironSource. They require a compressed HTML5 ZIP ad, max 5 millibit compressed. They have a 3-minute maximum duration, and a mandatory end card is required. Also, strict MRAID 2.0 compliance. AppLovin, they support a single inline HTML file, index.html, up to 5 millibit, both portrait and landscape. Requires MRAID 2.0. Crucially, SDK integration is essential for tracking clicks and performance. They provide their own AppLovin testing tool, and interestingly, they offer in-house support via their Spark Labs team to help create high-performing playables, which can be a big help for larger studios. And finally, Mintegral. They offer flexibility, ZIP or inline HTML, 5 millibit file size limit, supports both orientations. Like others, SDK integration is required for tracking. They also have a Mintegral playable ad testing tool. The takeaway, each platform has its quirks. Always check their latest documentation. Always test specifically for that platform.
Absolutely. Test, test, test. Okay, wow. We've journeyed quite a way here. From building the core mechanics of a 2D physics puzzle game right there in Construct 3, exploring how to make blocks bounce, stack, realistically, all the way to the really intricate art of crafting compelling playable ads. We've seen how, simplicity, strong hooks, and just relentless optimization, things like asset compression, continuous A/B testing, are absolutely critical to grabbing attention in what is a fiercely crowded mobile market.
And we've definitely highlighted that crucial yet often complex world of ad network compliance and the ethical considerations, too, which underpin responsible advertising, always emphasizing the importance of respecting the player's experience. From ensuring responsive design and using the right CTA functions to understanding those super specific file size limits and platform quirks, success in this space really is a continuous process. Constant refinement, meticulous testing, agile adaptation. It never really stops.
It really makes you think, doesn't it, how rapidly game development tools like Construct 3 are evolving, and how those advancements just intertwine with the ever-changing demands of ad platforms. When you combine that with the constant crucial need to respect player immersion, player privacy, it poses a profound challenge. So the question for you, our listener, is, how does this dynamic interplay, this constant evolution, push you as a developer or a marketer to embrace continuous learning and adaptation? What new creative strategies will you discover as you dive even deeper into this fascinating blend of technical skill, creative vision, and strategic thinking that really defines success in building and marketing engaging games today?